Welcome back to the channel, everybody. A few months ago I made a video regarding some of the problems with this 82 Trans Am with the Pontiac 301 in it, and I had a game plan. I was excited, but it kind of blew up in my face, and here's why. So I ended up finding this, and for those of you that can't recognize it, that's a push rod that's kind of buried into the lifter body, and that's a plunger that's sideways. Apparently the little circlip broke, and this has been causing the ticking that this engine has had for a while. What led me down this path was this cylinder number 8 had low compression for a long time, and I wanted to eliminate the ticking sound and see if this motor was actually bad. So the obvious next step was to remove the intake manifold and valley pan, check out the lifters, and of course this is what I found. So basically I'm going from a running engine, and yeah, it wasn't running perfectly, but I really want to investigate this noise because I just don't want this engine to get damaged any more than it needs to. I still want a baseline at the racetrack. So I recruited my son's help with this. He's shown some interest in the car, and I think it would be a good, kind of father and son thing to do, to take this thing apart, diagnose it, figure out what's going on, see what damage there is, if any, and see if we can, fix it with a new cam lifters, hopefully. Right now we're taking apart the radiator, and then we're going to get at the harmonic balancer bolt, then get the water pump bolts, timing cover, etc. Take the whole front end off of the motor. Right here we're reinstalling the water pump bolts, so that way we can keep track of them and not lose them. A nice little thing about Pontiacs and taking them apart is the balancers usually slip right off. This one was a little stubborn, so had to use some crowbars, but it came off without a fuss, really. Next we're removing the alternator, the wiring, and pulling it off the mount. Thankfully we can leave the power steering there because it's hanging off the side of the head, not in the way. After that it's timing cover bolts, and then the lower 4 oil Panta timing cover bolts. They actually came out pretty easy, and just took our time and got them out. So opening up an engine like this, especially of unknown origin, sometimes gives us little treasures, or at least tidbits of its past. So looks like this motor was rebuilt at one time, because I've seen brass freeze plugs and such. But also what's interesting is that they used a double roller timing set. So that's pretty good. It usually means they're performance oriented. An engine like this in the late 70s would have had possibly the plastic timing set that's notorious for breaking over time. So after doing some thinking and getting a game plan in my head, I'm going to take these 2 valve springs off right now, because I want to measure them. I want to make sure they're okay and they're up to par with a new cam. If they're not, I'm going to replace them. But the other thing I'm going to check is I'm going to measure the valve guide to seal clearance, and then the retainer clearance to the valve guide, and see if I can coax a way to get a bigger cam in here. So right here I'm taking the spark plug out of the cylinder. Plan is to feed some rope into the cylinder and then rotate it so that it locks up and crushes in the combustion chamber, so that way I can use my valve spring tool and collapse the valve springs and pop off the retainer locks and get the springs off and do all my measuring that I need to. So right here I'm feeding rope into the cylinder. The goal is to get enough rope in there so that way when I rotate the motor, the piston comes up, pushes the rope up against the valves, and I can use my tool to allow that pressure to be pushed down, but the valve stays up, and that's when the locks come up. So now it looks like the motor is sufficiently locked up, and we get to try the tool out. So when I do this, I try to tap the tops of the valves with a rubber mallet. This allows them to kind of free up because the locks are under tremendous amounts of pressure on the retainer, and it just helps free them up. Here's my valve spring compressor tool. It's actually made for a small block Chevy, but I use it with a little bit of a Allen wrench to work with Pontiac. So after lots of fussiness, here I am trying to pull the valve up just slightly. Also trying to spread the keepers so that way I can use a magnet, or I could just push them out of the way and they can release from the valve. There's a lot of tension on there and the angles are bad sometimes, so that's what takes a long while to pull locks off. Sometimes they're just stuck. And here we go, valve spring came off. Awesome. So, since we were successful at doing that, now we remove the tool off of this cylinder. This was the exhaust side of cylinder number 2. Then move it right next door to the intake side of cylinder number 2. And then we're going to repeat the process and hopefully bust this valve spring off. Hopefully a little bit easier, but we'll see. They always fight, especially a motor that's this well worn. This one was much easier now that intake valve spring is off. Now we can remove the tool and do our measuring. So these valve seals are hard and brittle. One of them cracked, one of them stayed on, and I had to get it out with a pick. But here I am using my height micrometer that's specifically for valve springs. I'm using a factory retainer and a CompCams retainer that I use as a test retainer. And this is going to allow me to do all the measuring I need to figure out where the valve is, where the springs are, whatever the installed height is, if it's inch 800, inch 700, inch 750. This will tell me a lot. This will tell me what spring I can put in there and all the important things for getting the right spring in there for the cam I choose. So right here I'm showing the micrometer at 1/820. Now this is kind of deceiving because you can see the retainer is setting inside the micrometer. Well, that's an inside ledge that's not accounted for in the measuring. So it's actually inch 700 or inch 680 installed height. So now we get to do something very interesting that not a lot of people do. A long time ago I bought a valve spring pressure checker that allows me to see seat pressure, max lift, coil bind, things like that. And it's a tool that I use every time I build a motor or set up a set of heads. So we're going to see if these old dingy valve springs off this old tired motor are going to be adequate for a new cam. If they're not, then we for sure need to change the valve springs. So here we go. Let's see. We're looking for a target pressure at seat pressure of inch 700 of about 100 pounds, maybe 80 to 100, and that'll be adequate. If we get anything lower than that, they've got to go. We've got to replace them. So here we go. So now we're going to use my digital Proform valve spring checker. And it's a great tool. I use it all the time for setting up heads. I'm going to measure this at inch 800 because that's kind of the installed height I want. And I could shim it to that, or offset lock it, or offset retainer it to that. So I'm going to check it at inch 800 even though technically it's inch 700. But I guarantee you the 100th thou difference adds like 15 pounds to this. So as we could see here, I'm adjusting it to where I'm closing the vise to let it get to the inch 799, inch 800 mark. And then we're going to check and see what the pressure is. And it's already settling around 50 pounds. And that's just not adequate. You can't run any hydraulic flat tappet or anything like that with that little pressure. So next, we're going to check the open pressure, which will be around inch 400, so about 400 lift. And that pressure should be well over 200 pounds. But in this case, if you look at the digital thing, it's at 146 pounds at inch 400. That's just not adequate. That means these valve springs are spanked probably throughout the whole motor, so we're going to need to replace them. So here we go. So this makes my decision easy. Looks like we're going to have to do some upgrades. Thankfully, I have a shelf full of parts, and upgrades will be cheap and plentiful, and I have a lot of choices to make. So everything is because of this stupid little lifter failure. And the next video will be doing all the mods to make it better. Put down in the comments what cam you think I should go with. That Summit 204-214 or the Lanati 212-218. Once again, I really appreciate your support and thanks for following along. Hopefully it's been educational.